The surge in parks on the air, summits on the air, and casual field operating has sparked a golden age for portable antennas. When you are operating out of a backpack or the trunk of a car, the best antenna is always a practical compromise between electrical efficiency, deployment speed, and packed weight. Here is a breakdown of the four most popular portable antenna architectures deployed in the field today. End-fed half-wave EFHW, the reigning overall champion of POTA and backpack operating. An EFHW is a half wavelength of wire resonant on its fundamental frequency and its odd and even harmonics. For example, a 40 meter EFHW is naturally resonant on 40 meter, 20 meter, 15 meter and 10 meter. Because of a half-wave wire presents an exceptionally high impedance, typically 2000 to 3000 ohms, it requires a 49:1 or 64:1 unune unbalanced to unbalanced transformer at the feed point to bring the impedance down to your transceiver's 50 ohm output. Advantage: true multi-band operation without needing an external antenna tuner, exceptionally simple to throw into a tree as a sloper, inverted V or horizontal flat top. Uses your coax shield as a return, requiring minimal or no extra counterpoise wire. Disadvantage: high RF voltages develop at the feed point. The transformer's ferrite core can saturate or overheat if running high power 100 watt plus on heavy duty digital modes like FT8. Resonant linked dipoles. If your absolute top priority is uncompromised tuner-free signal efficiency and you don't mind a tiny bit of extra manual labor, the linked dipole is a legendary SOTA contender. It is a standard half-wave wire dipole cut for your lowest desired frequency band like 40 meter or 80 meter. However, the wire elements are interrupted by physical jumpers, alligator clips or 2mm bullet connectors, located at the exact resonant lengths for higher bands. Advantage: 100% radiation efficiency with zero matching transformer losses, provides a resonant 1:1 SWR across multiple bands, allowing you to leave the heavy antenna tuner unit at home. Naturally, low noise floor. Disadvantage: you have to lower the antenna center or reach up with a hiking pole to physically open or close the jumpers every time you change bands. Requires 3 physical tie-off points, a center telescoping mast plus 2 end stakes. Loaded coil verticals. When you are set up in a sparse desert park or on a rocky summit with 0 trees to hang a wire, self-supporting vertical whips are indispensable. A physically shortened aluminum or stainless steel whip is made electrically resonant using a variable loading coil at the base or center. You tune it by manually sliding a metal collar up and down the coil or switching tabs until the noise flow peaks. Advantage: 100% tree independent. Sets up in 5 minutes on a lightweight photography tripod or a ground spike. Offers a low takeoff angle that is fantastic for long distance DX contacts. Disadvantage: radials dictate your success. A quarter-wave vertical is only one half of an antenna system. Your ground plane makes up the other half. Without laying down several elevated radials or a wide spread of ground wires, your efficiency drops precipitously. They also exhibit very narrow 2:1 SWR bandwidths on lower bands like 40 meter. Small magnetic loops or mag loops for extreme space constraints such as operating from a concrete picnic pavilion, a cramped hotel balcony or a dense urban park. The magnetic loop is a brilliant piece of specialized engineering. A continuous highly conductive loop of thick aluminum or copper tubing, usually 1 to 2 meters in diameter, acting as a high Q parallel resonance circuit. It is brought to resonance via a high voltage variable capacitor mounted at the top of the loop. Advantage: unbeatable physical footprint, responds primarily to the magnetic field rather than the electrical field, which makes it virtually immune to local man-made electrostatic noise, requires zero ground plane radials or tall masts. Disadvantage: extremely narrow operational bandwidth, sometimes just 5 to 10 kHz wide on 40 meter, meaning you must readjust the tuning capacitor every time you spin the VFO dial. Expensive to purchase commercially, develops thousands of volts across the top capacitor even at 10 watt QRP power levels. Weighing your field priorities. Because no portable antenna does it all, finding your personal match comes down to deciding what you are willing to compromise on. The field rule of thumb: if you have trees, pack an EFHW and fed half wave. If you have open dirt and a telescopic pole, run a linked dipole. If you are above the tree line on bare rock, deploy a loaded vertical. If you are boxed in by concrete and power lines, set up a mag loop.